All right, class, we are going to be filling in the bottom section the bottom flap of section number 1 in your Unit 11 flipbook called Quadratic Relations. This first video is just basically review, but if you are still struggling with finding distance or midpoint, then this video is for you to help you refresh your memory. You'll need these skills for this unit. So let's take a look. The first box here I'm going to label as Pythagorean Theorem. And the question is, what is the distance from point A to point B? Well, I guess we probably should label point A and point B. So let's do that. So let's call this one point A. And here is point B. And the question, what is the distance? What is the length of this segment? Is the same thing as asking what is the distance between A and B. Now this segment is on a grid, on a coordinate plane, so we can use Pythagorean theorem pretty easily here. Let's turn this diagonal line into a right triangle. You see right here I'm making a right angle. Let's go ahead and identify the length of the legs. 1, 2, 3, 4, that is a distance of 4. 1, 2, 3, 4, that's a distance of 4. And we know we can use Pythagorean theorem here because a squared plus b squared will always equal c squared if we're looking at a right triangle. A and b are the legs of the triangle. C is going to be the actual length of the hypotenuse, which will be the distance from A to B. So A, let's say A is the leg that's 4 units, B is the leg that is 4 units, equals C squared. 4 squared is 16. 4 squared is 16. That's going to equal C squared. 16 plus 16 is 32 equals c squared. And now remember, class, to get rid of a square, we square root. So we're going to end up with c is equal to the square root of 32. And we put that in our calculator, we're going to get approximately 5.7. And we don't know what the units are for this particular graph, so we're just going to label this as U for units. So 5.7 units. Alright, so there's a refresher of how to use the Pythagorean theorem in a coordinate grid. Next one is distance formula. Distance formula. Find the distance between A, which is at -1, 1, and B, which is at 3, 5. So using the distance formula, if you recall, class, we're going to label the x and y values of each of these coordinates. I'm going to rewrite them here. Here's A, -1, 1. We've got B, which is 3, 5. And if you recall, we would label them x sub 1, y sub 1, and x sub 2, y sub 2. Now some of you might remember from our original flipbook, I taught you a shortcut for the distance formula. I have no problem if you use this, but I'm going to still use, in this case, just the distance formula. The distance formula is the distance between any 2 points is equal to the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. And that whole thing is square rooted. Let's go ahead and plug in what we know. So the distance is x sub 1 is -1. Sorry, x sub 2. Let's put x sub 2 in there. Might as well follow my own formula. X sub 2 is 3 minus, that's part of our equation, x sub 1 is -1, so it's minus -1 squared, plus y sub 2 is 5 minus, and the y sub 1 is just +1, so we write that once. Let's get that in a square root. We can see in this case this is 3 plus 1. 3 minus -1 is just 3 plus 1. So we're going to end up with the square root of 3 plus 1 is 4 squared, plus 5 minus 1, that's also 4 squared. We're almost there. This is equal to the square root of 16 plus 16, which is equal to the square root of 32, which is again approximately 5.7, and we don't know our unit of measure, so it's 5.7 units. Now class, I'm going to show you, I use the same coordinates for this column as I did with the graph, just to show you that distance formula, Pythagorean theorem, they'll give you the same answer. Alright, last warm-up or review is midpoint formula. Find the midpoint of A at -1, 1 and B at 3, 5. Same thing for midpoint formula. Sometimes a good strategy is just to go ahead and write the coordinates so you can label them. And we're going to do the same thing here. I'll just label this x sub 1, y sub 1. Let's try a 1 there. And x sub 2, y sub 2. Now I could have labeled this x sub 1, y sub 1, and this x sub 2, y sub 2. It makes no difference, just as long as you keep the sub number the same sub number in the one coordinate, and the x value is always the first number, the y value is always the second number. Okay, let's write our midpoint formula. The midpoint formula is, we've got x sub 1 plus x sub 2 over 2, and y sub 1 plus y sub 2 over 2. And let's plug in the things that we know. We know that x sub 1 is -1, x sub 2 is +3 over 2, and y sub 1 is 1 plus y sub 2, which is 5 over 2. Let's go ahead and simplify this. -1 plus 3 is 2 over 2. 1 plus 5 is 6 over 2. And one more simplification here. 2 over 2 is equal to 1. And 6 over 2 is equal to 3. So our midpoint is at 1, 3. 1, 3. Now I use the same coordinates A and B. Let's plot that. 1, here's our origin. 1, 1, 2, 3. So you can see, class, that midpoint makes total sense for this particular segment AB. So there is your review again of Pythagorean theorem, or finding distance with the distance formula, or using the midpoint formula.